Alright, this is the last video lesson for the year. We're basically just going to go over, it's going to be the same PowerPoint you saw today in class. But hopefully, this can be a little bit tricky, can be a little bit difficult, especially, the case where you get 0, 1, or 2 solutions. So this you have, to hold on to. You can watch it over and over again, so, you can understand this topic and go at your own pace. Alright, let's go to the PowerPoint we did today in class. I don't know, maybe seeing this 2 or 3 times, then you'll definitely understand it. The side-side angle case, this is when you're given one angle, and the angle is not in between the two sides. And there's 2 cases. One is when the given angle is acute. The other is when the given angle is obtuse. And then there's 2 cases within case 1. Now, when you have side-side angle, you're going to be given the opposite side and the adjacent side relative to the angle that you're given. Now, when this opposite side is shorter than the adjacent, this is where there's a lot of the thinking going on. This is where it can be a little confusing. It's why we say this is the ambiguous case, because it's not very clear. Okay, there's 3 types of answers. Okay, you can get 0, 1, or 2 solutions. 0 means the triangle doesn't exist. Okay, 1 means that only one triangle exists. 2 means that you can get 2 different types of triangles for the information given. Now, let's go over the picture for this. This is where we want to get our understanding. This is real important to understand this. Okay, 0 solutions. Okay, if I draw this right here, this is the given angle A. Obviously, you can see how I drew this. This is acute. This is the opposite side, A. And then this is the adjacent side. Now, according to this is the opposite side. This is shorter than B. Now, what's going to happen here is either this side is not going to be long enough to touch this side. Even if you swing this side in, or swing it out, it's still not going to hit this bottom, this horizontal line right there of the triangle. That's when you get no solution. So if you set up your law of sine, you're going to have little a over sine of A equals little b over sine of B. And when you hit inverse sine for it, you're going to get error. So when you solve for angle B, if it comes up error, that means this is what your picture looks like. A is too short. And sometimes when you look at the side lengths that you have, you can kind of tell, like if this side B is, let's say, 20 and side A is 4, well, it's probably not going to be long enough to hit this third side. So you can kind of use just kind of logic there. Okay, the one where you get one solution is, I'm going to draw it the same exact way, but that opposite side A, now I'm going to make it exactly long enough. Now, if I make this exactly long enough, imagine if all these were pieces of string. If I make this exactly long enough, it's going to form a 90-degree angle. Now, even if I take this side and I swing this in, think it kind of like a pendulum. If you swing this in, then it's going to go from like here to here. It's not going to hit this right there. So you're not going to get a triangle there. If you swing it out, same thing. It's going to go from like here to here. So this is the only triangle you can get. Same thing. This, is highlighted. When you solve for this angle B, you're going to get 90 degrees. So that means A is exactly long to get one triangle. So you only get one solution for this angle. Okay, the trickiest one, the 2 solutions, this is where you really have to take your time, and you're not going to get the answers right away. It's going to take you the longest to do these type of problems. When you do take the quiz on this on Friday, it's, you might have one of these. Probably just have one of these. All right, now this is what's going to happen. Now, remember that last case. This is a 90-degree angle. If I extend this piece of string, well, there's 2 things I could do to this to make 2 triangles. I could, let's put the other, whoops, okay, I could take this, and if I swing this in, then it can touch here, and it's going to make this side longer, and you get a smaller triangle. This is what that's going to look like. Right? If I swing this in, then it looks like this triangle. Now, the other thing I can do, since this is long enough, I can swing this out. Right? If I swing this out, then what's going to happen is this bottom, it's going to make this bigger, and it's going to touch that, so you're going to get a bigger triangle, and it's going to look something like this as I'm highlighting it here. Okay, and this is also to finish the last triangle. All right, let's swing this one out, and this is what this triangle looks like. Okay, now notice what's the same. Angle A is still the same as angle A here. Side B is the same. And side A are the same. What changes are these. This angle changes, and therefore this side changes. So in each of these two triangles, the information that's given is the same in each of the two triangles. The other three pieces of information is going to change. Okay, and knowing from class, when you solve for angle B, you're going to get an angle that's not 90 degrees. So, and you can look at this. This is angle B sub 1 is bigger. This is acute. This is bigger than B sub 2. All right, that's what I have here. Let's see here. This angle, to kind of compensate, this angle is going to be bigger than C sub 1. And if you draw it, to scale, you can easily see C sub 2 is bigger than C sub 1. And therefore, this side, obviously, little c sub 2 is going to be bigger than little c sub 1. Alright, so that's a lot right there. Okay, you might have to rewind this and go over it again to really understand it. But this is, we're going to refer back to this when side A is long enough and you get an angle here when you solve for this. If it's not 90 degrees, we're going to get these two cases. It's really important for you to draw both of these triangles out and to really understand everything that's on this slide right here. Alright, let's look at an example. Let's apply this now. Okay, 65 degrees, that's an acute angle. So I draw it so it's acute. Put the 65 degrees in there. A is opposite from it, it's 11. And then the adjacent side is 25. This is what we want to figure out, angle B. Now again, this is the case. The opposite side is shorter than the adjacent side. So it's either going to be 0, 1, or 2 solutions. Now let's just kind of use logic here. This is a lot smaller than the 25. So I'm guessing here it's probably not going to hit. So when we set this up, and that's our question, is A long enough? So I leave it like that. I don't know if it's long enough. So when we set this up, law of sine, it's 11 over sine of 65. This is B over, and this is angle B. So it's 25 over sine of B. When you cross multiply, you're going to have 25 times the sine of 65. And you're going to divide by 11. So if sine of B equals this, whatever this quantity is, hit inverse sine of it. Make sure you're in degree mode. And when you do that, you get error. So that means that there's no solution. This triangle doesn't exist. So this is what the picture looks like. 11 goes from here to here. You swing it in or swing it out. It's never going to hit this side. So that triangle does not exist. Now, as we did the second one in class, now I still have 65 degrees for the angle. But now I'm going to make this opposite side longer because I want it to hit. So now I make this longer, 23. I still make the adjacent 25. So I'm going to set it up the same way. So I'm going to have little a over sine of A. So 23 over sine of 65 equals little b over sine of B. Right? I cross multiply these and I'm going to divide by 23. So 25 times the sine of 65 divided by 23. When you hit inverse sine, you get 80.1 degrees. Now this is the case. This takes you a while. This is going to take you a long time to get all these answers. And we're going to find out all the angles here and all the sides for two triangles. It's not 90 degrees, so therefore it's two solutions. Okay, let's put this 80.1 degrees in here. Alright, let's just draw these two triangles. Okay, and this is the bigger triangle when we swing the side A, which is 23. When I swing this out, right, I get this bigger triangle. Now I got 80.1 degrees. Now to get the other one, it's going to be 100 minus 80. Or excuse me, 180 minus 80, which will give you 100. This angle right here is going to be bigger. Now this is going to be the 80.1 because that's smaller. Alright, to get this, I'll say B prime. It's 99.9. We do 180 minus it. This is going to be the 99.9. And this is going to be the 80.1. You can tell just by looking at the picture. It's like they say, a picture tells you 1,000 different things, or it gives you 1,000 words. Whatever. Alright, okay, let's put the rest in. I'm just labeling it with the C's. And let's find this. To find this angle, C sub 1, well, we just take 180 and subtract the sum of 65 and 99.9, which is 15.1. So I can put that in. Now, if I want to find this side here, this little C sub 1, well, I can do this 15.1 over the sine of C equals 23 over sine of 65. So I just use law of sine. Okay, this is my cross product here. So 23 times the sine of 15.1, and then you're going to divide by the sine of 65. Okay, kind of the order switched around here a little bit, but still gives you the same thing. And when you do this, you get 6.6. So this is what this side is, 6.6. Alright, now let's find the other triangle here. This is 80.1. To get this angle, well, I just do the same thing. I add 65 and 80, and then I subtract that sum from 180, and this is going to give me, this angle here is 34.9. And to get this side little c sub 2, well, we do little c over sine of 34.9 equals the 23 over sine of 65. Okay, and there it is. Okay, you cross multiply, so it's 23 times the sine of 34.9 divided by this, sine of 65. All right, and then when you solve for that, now this is going to be, this should be bigger than that 6.6, and it is. You get 14.5. All right, so a lot going on there. Again, take your time if you need to rewind. Go over this. This is obviously the toughest problem that you'll see for the law of sine. All right, let's do another one. Okay, if I draw this picture, I have 30 degrees. Opposite side's 15.7. Adjacent side's 31.4. Again, it's either going to be the 0 or 1 or 2 solutions, so let's set it up. I want to figure out if A is long enough. So here it is, 15.7 over sine of 30 equals this, 31.4 over the sine of B. So I always solve for this angle B first. And, you know, after you cross multiply, you get these, sine of 30 times 31.4, and you're going to divide it by 15.7. And we do inverse sine of this, you get 90 degrees. So that's it. You only get one solution. So this is what it would look like. I would redraw this, and 15.7 would go from here to here. It would exactly hit. And then you would just have 90 degrees there. All right, case 1, given angle is a cube. Now, if I change this up, if I say the opposite side's greater than the adjacent, then it's real easy. You just get one solution. There's no thinking going on there. It's only when the opposite side is shorter than the adjacent side. All right, and here's an example right here. Okay, I have a acute angle, and that's 42 degrees there. I have A is 25, this B is 15. Now this opposite side's bigger than it, so you're just going to get one solution. And let's just solve for angle B. So to use law of sine, I'm going to have 25 over the sine of 42 equals 15 over the sine of B. Okay, and again, when I get sine of B by itself, I'm going to have 15 times the sine of 42 divided by 25. All right, make sure you hit inverse sine of this, and you get B to be 23.7 degrees. So this is 23.7 degrees, and then that's it. You can't swing it in or swing it out and get two triangles. That's your only solution. This is the only triangle you get. Okay, then we go to case 2, and the given angle is obtuse. Now it's really important when you draw these pictures, when the given angle is obtuse, make sure you draw an obtuse angle. You know, keep it to scale, and then it'll make sense when you put the numbers in. Now there's only two things that happen. Either the opposite side's long enough or it's not. There's no two solutions. Okay, so if you get error for it, that's it. You're done. The triangle doesn't exist. If you get an answer for it, it doesn't matter if it's 90 degrees or if it's 50 degrees. That's it. You only get one answer. You only get one solution for that angle B. All right, let's look at an example. Obviously, A is obtuse. It's 130 degrees. We have A. Little a is 52. B is 24. Now let's make sure I draw angle A is 130. All right, now you can see little a, this has to be, it's opposite 130 degrees, which is obviously the biggest angle in the triangle. This has to be the biggest side. So B, that's 24, A is 52. This has to be a lot bigger than 24 in order for it to exist. So just using, logic here, I'm probably thinking it's going to work out because it's long enough. So let's set it out. We're going to have 52 over the sine of 130 equals 24 over the sine of B. Okay, and then we're going to have the cross products. We're going to have 24 times the sine of 130 divided by 52. And then hit inverse sine of this. Okay, you're in degree mode. And you get 20.7 degrees. And that's a real small angle. That makes sense when you draw this to scale. And that's it. That's the only angle you can get for angle B. Okay, the last one, I'm going to make this a lot smaller, this side. All right. So again, we just get one solution there. All right, let's set this up. 115, that's obtuse. Okay, I put that in. B is 38. Opposite side's 20. Now, this doesn't make any sense. You can see right now, you're going to get error. This has to be, if this is 115 degrees, this is going to be your biggest side. It can't be smaller than 38. So you're going to get error. And then just to set it up to prove it, it's really not going to take you a whole lot of time. You just use law of sine, 20 over sine of 115. Equals 38 over the sine of B. So you cross multiply here, you're going to have 38 times the sine of 115, then you're going to divide by 20. Okay, and take inverse sine of it, And on your calculator, when you're in degree mode, you get error.